All right. The first thing we're doing. The first thing we're doing is I'm going to give you two simple questions. It'll be 3 points. So first one, um, 5 to the 6th power. I'm going to ask you to write it in words. And I'm going to ask you to write it as a product. You need to know when I say product, it's not to answer the question. It's to write it as 5 times 5 times 5 times 5 times 5 times 5. In words, it's going to be 5 to the 6th power. All right. I ask you one more time to please be quiet. So, that's going to be your first question. 3 points. Second question is actually evaluate. So if I give you, let's say, 3 to the 4th power, you're going to actually evaluate. Whenever you see the word evaluate, you think of it as solving. I'm going to actually get the answer. So to evaluate the power, you do 3 times 3 times 3 times 3. Either, if you have already bought a calculator, you could use your calculator. Or, and I'll show you where you could do it in your calculator, but it is 3 times 3 times 3 times 3, which ends up being 81. In your calculator, there is a button that makes exponents. So if I want 3 to the 4th power, I click 3. Then I pick this button, which is called a caret. It's above the division symbol. If you have the 284, it'll pop up here, and you type in 4. This allows you to do it in your calculator.
Why is it called a carrot?
That symbol? That I have no clue.
Why not like an apple?
I have no clue. Okay. Next one's evaluate expressions. This one is I'm going to give you some algebraic expression. 3x plus 2 divided by 5 when x equals 6. So in this situation, what I'm doing is replacing the variable with what it is. So 3 times 6 plus 2 divided by 5. This is also testing your order of operations. So since this is on top, this is going to happen first. So this is going to be 18 over plus 2 over 5. In this scenario, you're like, oh, now do I divide? Technically, this is in invisible parentheses because it's on top of a fraction. So you got to take care of both top and bottom by itself first. So 15 plus 2 is 20. Then divided by 5, your final answer is 4. So this is testing out both order of operations and plugging in the variables, okay? Remember, if you have multiple variables, 4x minus 2x when x equals 7. When you have multiple variables, you plug it into every variable you see. So 4 to the 7 minus 2 to the 7, which is 28 minus 14, or 14. Okay? Every variable you see gets to be plugged in. Every variable you see gets to be plugged in. If I give you multiple variables, 2x plus 3y, when x equals 2 and y equals 5, just make sure you're placing them in the right place. X's become the number, y's become the number. 2 times 2 plus 3 times 5. 4 plus 15 equals 19. So make sure you put the right number with the right variable. The next thing you're doing is check for a solution. So I'm going to give you some equation. 6x minus 2 equals 3x plus 5 when x equals 2. My key does not work. So what I'm going to do is plug in 2 into every x I see and check if it's a true answer. So 6 times 2 minus 2 equals 3 times 2 plus 5. 12 minus 2 equals 6 plus 5. 10 equals 11. In this scenario, they're not equal. So in that case, the answer is no. You need to show work in this section and in all sections. Oh, there's also check a solution if it's an inequality. So 2x plus 5 is greater than or equal to 9 when x equals 2. Again, you plug it in. 2 times 2 plus 5 is greater than or equal to 9. 9 is greater than or equal to 9. Since it's greater than or equal to, this one's a yes. 9 is greater than or equal to 9. So this is a yes. Remember, if it looked like this, 9 is just greater than 9. That is not a true statement, so that's a no. So remember the difference between greater than or equal to and just greater than, or vice versa. Less than or equal to or less than. On your test, you're going to have to translate verbal phrases. Yes. No, I'm saying in the red situation, like this, it's not connected to the question. It's like a separate situation. If it was just 9 greater than 9, that situation is a no. But in the black, it was 9 is greater than or equal to 9, which is a yes. I'm just pointing out they're different. So you're going to have to translate expressions. So 13 less than w squared. So 13 less than w squared. Remember, if I say 13 less than, not is less than, but less than, that means that I'm going to subtract 13 from whatever I get. So I'm subtracting 13. Less than w squared. You need to know the word squared means w to the second power. Some people might get it confused with 2 times w. It's not. It's w to the second power. The difference between half of x and 7 is no more than 20. Right. The difference between half of x and 7 is no more than 20. So in this scenario, the difference tells me it's a subtraction problem. Half of x. So half of x, you could think of it as 1/2 times x. You could also write it as x over 2. Those are the same thing. Guys in the back. So the difference between half of x and 7 is no more than 20. It cannot be bigger than 20, so it must be less than or equal to 20. When again, it's no more than 20, so if it can't be more than 20, it must be less than 20. Yes. Yes. As a reminder for the video, cut it out. As a video. Sum is addition. Difference is subtraction. Product is multiplication. And quotient is division. 12 is less than 10. Oh, wait. Oh, sorry. I shouldn't say 12. x is less than 10, but more than, and more than 4. So this is a basic one of the ones we've done before where we have a double situation. X is less than 10. This is a is less than. So x is smaller than 10. And an x is more than 4. So x is greater than 4. So we have to combine it into one situation. I always like to start with the smallest. So 4 is less than x. Because remember, if x is bigger than 4, then 4 must be smaller than x. So 4 is less than x, which is less than 10. This should be your final answer. It should be one expression.
How would it be like in the word problem? It says 1/2x minus 7.
Yeah. That is half of x. So half of is multiply x and 7.
How
So
would it be in the word problem, but it's like other way around? Like
7 less than half of x. You could say it like that. 7 less than half of x.
at first, in the last one, would it always be like two separate?
It's two separate that you have to combine together. Okay?
Have to?
You have to. It's one expression. This is one expression. These are two separate expressions. So you have to combine it. If you just leave it like this, you'll get partial credit. But this is for full credit. All right. Next part is functions. So y equals x to the third power minus 1. Give me the domain. Here's the domain. Let's put -1, 0, 1, 2. Please give me the range. So you've got to find the range. So the range in this case is the answer to each question when I plug in the domain. So for example, -1 to the third power minus 1. I'm taking this number and plugging it into the equation. -1 times -1 times -1 ends up being -1. So -1 minus 1, -2. So that one's a -2. Then I plug in 0. 0 to the third power minus 1. 0 times 0 times 0, it's just 0. 0 minus 1 is -1. Give me a purple. 1. 1 to the third power minus 1. 1 to the third power is 1 times 1 times 1, which is 1 minus 1, which is 0. All I'm doing is I'm taking this number over here in the domain, then I plug it into this equation. So it's going to be 2 to the third power minus 1. Yeah, then I solve it. 2 times 2 times 2.
Wait, you have to do it for all the numbers?
All the domain I give you, you have to do it for all the range. You don't have to show all the works of it. You could just give me the answer in this one.
So suppose the domain to like
X.
all
All 4 or 5 or 6 or whatever I give you. Okay? 2 times 2 times 2 is 8. 8 minus 1 is 7. So this is a function. This is the range of said function. I might give you a function, and I ask you to give me the table and the graph. Let me change this up, actually. Let's do x minus 1. So the table, I'll have it printed out for you so you don't have to make a table. And I'll have a graph for you so you don't have to make the lines either. Well, let's say, to make the simple one, let's start at -1, 0, 1, 2. So your table is going to look like that. What you're doing is you're going to fill out the y, and you're going to have to make a graph, or you already have a graph made. you're going to have to graph it onto the thing. Your graph will always be a 5b5 on this one. So what you're doing mathematically wise is what you're doing is you're plugging it in just like before. Since I did it in the last question, I'm not going to spend too much time on the video. And when you watch it, if you watch it, you could pause and just do it yourself first. But this is after I plug it into this equation. These are the numbers that will pop up. Now remember, each point is its own coordinate point. So -1, -2 is its own coordinate point. So that means for this one, I'll make this blue. For this one, I go left 1, down 2. For 0, -1, it'll be here. For 1 right, 0 up and down. That's the purple one. And let me get an orange. And then for this one, 2, 1, that tells me 2 right, 1 up.
If you put more than that amount of dots, can you get like 20 dots?
Since I'm asking you to graph this table, yes, because you're supposed to only graph what I give you. In future questions, maybe not, but okay. I'll sort it. Okay. So you have to make a table and you have to graph. Last one is a function question. Is it a function or not? So in this situation, I'll probably give you a list of inputs and outputs. So if you have 1, 2, 3, and this is like 4, 5, 6. Remember, the rule for inputs and outputs is this. Every input only has one output. So 1 goes to 4, 2 goes to 4, 3 goes to 6. In this situation, it is still a function. Every input has one output. Versus this situation, 1, 2, 3, 4, 5, 6. In this situation, where 1 goes to 4, 1 goes to 5, and 3 goes to 6. In this situation, this is not a function. Because it's not a function, because every input, in this case 1, goes to both 4 and 5. Remember, I don't care if they have the same output, but it really matters to me if one input does not produce 2 separate things. It should be, every input should only produce one thing.